Trig equations and identities. This is the work relating to exercise 10E from the exercise. These are slightly harder trig equations, very similar to the ones for 10D, but there's an added little trick here you need to deal with. Probably best explained by going through some of the examples. So I'm going to go through 3 examples here. First one is solving this equation, cos 3 theta equals 0.766. Notice now we have some multiple of theta. We can also have something added or taken away from theta. The range of values for theta for this one is between 0 and 360 inclusive, and that's quite important. The first thing we're going to do is we're going to find out what values 3 theta could take. Now if theta is anything between 0 and 360, then 3 theta can be anything between 0 and 3 times 360, which is 1080. So 3 theta, this angle here can be anything between 0 and 1080. So 3 theta, let's find out what our principal value is, our primary value. And we are in degrees here, so I better set my calculator to degrees. Okay, shift cos 0.766, 40 degrees. That's just our primary value. We can have any value of 3 theta between 0 and 1080. So we'd better do a little cast diagram here, or if you want to draw out the graph for cosine, feel free to do it and do it that way. So 3 theta is 40. 40 degrees is approximately there. C-A-S-T. It's positive there for all of them. We're dealing with cosine, so cosine is positive down here as well. Cosine reflects in the x-axis, remember, or theta axis. So we can have any value that corresponds to one of these 2 lines. So we've got 40, then we can have this one here, which is 360 take 40, which is 320. Now 3 theta can go anything up to 1080. So we've got some more values to contend with. We can go all the way around and then add on another 40, so we can have 400, or almost twice round. So twice round, take away the 40, 720, take away the 40 is 680. 360, 720, and then we can go once more. 720 plus the 40 is 760. 3 turns round will be 1080, less the 40 is 1040 degrees. So 3 theta can be any of these, so theta can therefore be any of these divided by 3. So 40 over 3, 320 over 3, 400 over 3, 680 over 3, 760 over 3, and 1040 over 3. Those are our values. How you leave them is largely up to you, so long as they're simplified. Just looking at these, none of these simplify into a whole number. You can leave them as top heavy, leave them as decimals, or leave them as a mixed fraction. Entirely up to you. So the trick here is to find out what 3 theta can be first, all the values that 3 theta can be, with your upgraded range of values for 3 theta, and then once you've found all those, then divide by 3. A common mistake is that students work out the primary value, 3 theta is 40, divide that by 3, so they get one correct value, but then they plot that on the cast diagram and work them out from there, giving you incorrect values for the rest of them. Let's have a look at another one. That's the first example. Example 2. 2 sine 2 theta is cos 2 theta. Well, our first problem here is we're trying to solve an equation which has two different trig functions in it. Always try and get down to one trig function. Now later on in the next chapter you'll see how you can get down to sine squareds and sines, or cos squareds and coses. We can solve equations like that, but when they are different, a sine and a cos, that can make life quite tricky. So we're looking for a way of simplifying this just to get one trig function. And if you remember back to an earlier session in this chapter, you remember that sine divided by cos is tan. So if I divide both sides by cos 2 theta, I get 2 sine 2 theta divided by cos 2 theta equals 1. Sine over cos is tan, so 2 tan 2 theta equals 1, and tan 2 theta is therefore a half. So now I'm going to find out all the values of 2 theta for which tan 2 theta equals a half. So I'm just going to press a few buttons on my calculator. You may know this one already, but if tan 2 theta is a half, I'm in degrees, shift tan 0.5 gives me 26.6. Common error here would be to divide this by 2. That will give you one correct value, but the rest of your values will be wrong. So I'm going to leave that like that for now and find out what the rest of my values are. Now the range here was once again between 0 and 360. So I need to know what 2 theta can be between. Well, if theta is between 0 and 360, 2 theta can be, between 0 and 720, just multiplying it by 2. So I need all the values of 2 theta, which tan of 2 theta gives me 26.6. Sorry, tan 2 theta gives me half. One of them is 26.6. Now I need my cast diagram. C-A-S-T, cosine all sine tan, 26.6. It's going to be about there. Tan rotates around the origin, so that's 26.6. This is 26.6. So all the values of 2 theta between 0 and 720, that's the first value. The second value is this one here, so that's 180 plus 26.6, 206.6. Then I do a complete turn, add the 26.6, so that's going to be 360 plus 26.6, which is 386.6. And there's one more value, that's 360, 364, 65, 540, 540 plus 26.6 is 566.6. Any more values going around and round here will take me beyond the 720. So if 2 theta is those, theta is just each of these divided by 2, so 13.3, 103.3, this one is 193.3, and this one is, that's a 6 there, so 283.3 degrees. Okay, one more. These ones we've looked at so far just have some multiple of theta, but we may also have something where we've added something on. Let's have a look at an example like that. So what if we're asked to solve sine x plus 60 equals 0.3, and that's for values of x between 0 and 360. First off, find my primary value, so x plus 60 shift sine 0.3 gives me 17.5, so my primary value is 17.5. I'm now going to find my other values before I take away the 60. So let's find my range first. If x is between 0 and 360, then x plus 60 is between 60, just adding 60 onto that, and let's add 60 onto that. So that's going to be 420. So I'm looking for other values other than 17.5 for sine that's in between that range. So let's do a cast diagram. 17.5 is going to be something like that. C-A-S-T. It's positive here. Sine is also positive over here. Remember, sine reflects in the y-axis. This is 17.5. This is 17.5. So another value is 180 take away 17.5, which is 162.5. Another value is going to be 360 plus the 17.5, so 377.5. Better have a look at this one. So 360 plus 180 is 540. 540 take away 17.5 is 522.5. That's more than our maximum value, so we can ignore that one. Now I'm going to take 60 away from each of these. Now this value here is not in my range. It's less than my minimum value, so I can ignore that. I'm just going to take 60 away from that one, 60 away from that one to give me what x is. So 162.5 take away 60 is 102.5. 377.5 take away the 60 is 317.5, and those are my two values. So the principle is the same. We work out all the values, all the angles that this could be first, all of them, and then we sort out the plus 60 by taking 60 away. So what I'd be looking for, our revised range. So I'd be looking for this. I'd be looking for my list of angles, which this can be. And then the last thing is to sort out the plus 60, or the times by 2, or the times by 3 take 10, or whatever it happens to be. So this is the last bit that you sort out.